Assalamualaikum. Hi guys. In this video we are going to focus the next subtopic for chapter 2, which is quantum mechanics. These all are the objectives that we have to learn for this part. So I'm going to introduce to you quantum mechanical models. So quantum mechanical models is what you are going to use for describing the possibility of placing electron within an atom. In the previous video, you've learned about several findings. For example, there are de Broglie's postulate and Heisenberg uncertainty principle, where you can understand that the quantum mechanical model of the atom treats electrons as a matter waves. So in the previous video, we learned that it is not possible for us to locate the position of electron in an atom. We cannot say that this electron in the first shell stays here. Maybe it will move around and we cannot find the fixed position for that. So that is why we are going to use quantum mechanical model to describe the atomic model for an atom. In this case, we are going to use atomic orbital. So I hope you still remember from the previous video, you've heard about the term orbital. So orbital is what we are going to use to explain the behavior and probable location of an atom's electrons. So we are going to find out what are those things in the next part. So as I mentioned before, quantum mechanical model use atomic orbital. So what is orbital? Orbital is a three-dimensional region in a space around the nucleus where there is a high probability of finding an electron. You have to imagine it is a big area in three-dimensional region in space. And that area we can find an electron. So this orbital is where the position of electron can be expected to be. And we are going to use another term, which is orbit, to show the path of an electron as it travels circling the nucleus of an atom. So let's continue a bit further. In orbital model, you have to understand electron is described as occupying a three-dimensional space around the nucleus. When we talk about two-dimensional space, we know that as in graph, x-axis and y-axis. But in three-dimensional space, we are going to add one more axis, which is z-axis. As you see from here, this is one of the example for orbital, s orbital. You can see the shape is spherical with three different axes here, x, y, z. And you can see this big sphere is the area where there is a high probability of finding the electron in this area. We also got another example, p orbital. So same goes, this is the area but the shape is different. So you have to understand the nucleus is being surrounded by electron cloud, and this electron cloud makes up the shape of the orbital. For example, electron cloud produce the shape as spherical like this or as a dumbbell like this. So you have to know orbitals also differ from one another in terms of their energy, shape, and spatial orientation of their electron cloud. So from here, in one orbital, you are going to describe the position of electron by using quantum numbers. So what is quantum numbers? Quantum numbers is a study that involves how the electrons are being placed in the orbital. So in quantum number, you have to use four different terms. This is what we call as four characteristics. The first one is principal quantum number. The symbol is small letter n. Next, angular momentum quantum number. You also got another different name for that. It goes for the same thing, which the symbol is L. Next, we have magnetic quantum number. The symbol is M. And last one, electron spin quantum number. These four quantum numbers we are going to use to describe one electron in the electron cloud. So I will continue for a bit explanation about these four quantum numbers in the next video. That's it for now. Bye!